Alright, so the very top here, we need to write in our functions for exponential growth and exponential decay. So we know we're going to have y equals, then what? A, and what does that A stand for? Initial amount, so whatever you start with. What goes inside your parentheses? If we're talking about growth, what are we going to put? 1 plus r, and then what else do you need? X is where? Your exponent. Good. Remember, that's what makes the exponential function. If the x is not in the exponent, then it's not exponential, and that's not at all what we're doing, yeah? So for exponential decay, what's the only difference for our equation? So we still have a, 1 minus r to the x. Is that okay? Some of y'all are saying like r minus 1, but that's going to give you the wrong number, so make sure that we're doing 1 minus r, 1 plus r, okay? Not the other way around. Inside those numbers, inside those parentheses, we say that's your b value, correct? So when the b value is bigger than 1, what does it have to be? If it's bigger than 1, what does it have to be? If it's less than 1, what would it have to be? Decay. Yeah, are we okay with all that? I'm trying to think if there's anything else that we need to like review. Are we ready to start? Yeah. Okay, cool. So this should be pretty easy. So for the first one, it says since 1985. I'm going to underline that because why is it important? So we're going to have to like not use whatever year for our time, right? There's going to be some time since then, right? So it says the daily cost of patient care in community hospitals in the United States has increased about 8.6% per year. In 1985, hospital costs were an average of $460 per day. The equation right here models the cost of hospital care. Use your equation to approximate the cost per day in 1995. So if we want to know the cost in 1995, how much time has passed since 1985? 10, so x is going to be 10. And they already gave you your function, so what do we need to do? Just plug in, right? So you'll be doing 460 times 1.086 to the 10. What do we end up getting? Is that okay? Questions? Okay, cool. So the next one, suppose your parents deposited $500 in an account paying 6.5% interest compounded annually when you were born. Here's your equation. It models the amount of savings. So use your equation to find the balance after 18 years. How are we going to do that? Just plug in 18. I put too many zeros. And what do we end up getting there? Is that okay? Questions? Okay, cool. So for the next one, there's your function. It models the average annual cost in dollars for tuition and fees at a public two-year college. The variable x represents the number of years since 1980. So what was the average annual cost in 1980? So what happened in 1980? Is that when we started? That's where we start, right? So at what amount did we start at? 355. That's pulling out that a value from your function, yeah? So what is the average percent of increase in the annual cost? So they want to know that rate. How are we going to find it? 1.08 minus 1, right? Because we know that 1 plus some rate gave you that number. So 1 plus something gave us 1.08. So what was that something that they added in? 0.08. Convert that to a percent. What do you get? 80%. Is that okay? Right, the next part there, it wants to find the average cost for 1990. So can we just plug in 1990 for x? Why not? We started in 1980, so how much time has passed? So what are we plugging in for x? 10, so do that. So when we plug in 10, what do we get? So we're talking about costs, that's money. So how many places should we round? So 42. That okay? Alrighty, next part, using the table function on your calculator, predict the average annual cost for the year that you plan to graduate from high school. So when are we going to graduate high school? 2022. So 2022. How many years after 1980 is 2022? 42. So what are we plugging in for x? 42. So you can use the table on your calculator, or if you just want to plug in x, that's fine as well. 42 is kind of a long way to scroll. So I would just plug it in on the calculator screen. Just plug in 42 for x. So when we plug that in, what do we get? Is that alright? Questions? Okay, so the next one, in the United States for the period 1980 to 1998, the function right here describes the fatality rate per 100,000 due to motor vehicle accidents. So assuming the model continued to determine the number of fatalities in the year 2000. So what year did we start? 80. So to 2000, how much time has passed? So what are we plugging in for x? 20. So what did we end up getting from the calculator? 2887. So does that mean that there were 15 deaths in the year 2000? Is that what that means? So what did it say? That it's in 100,000? So how many zeros are here? 5. So that means you move your decimal place 5 times. So if you, in your calculator, do times 100,000, it'll give you the rest of the decimals, so you can do it that way, or we can just move our decimals from here and it'll kind of be rounded. So you could do 1, 5, 2, 8, 8, 7, again, 1, 2, 3, 4, and there'll be a 0 behind it. Is that okay? About that many? Does that make any sense?
Yeah.
So you kind of get what we did there. Questions on that one at all? Okay, cool. So then moving on, an investment of 1,000 earns 3.75% interest compounded annually. Write the equation to describe the situation. So is it going to be growth or decay? Growth. So what is the rate that we're talking about? 3.75%. Make that a decimal. What is it? How are we going to find the growth factor? Add 1, so that's going to be 1.0375. Then to write our equation, you're going to have y equals. And how much money did we start with? 1,000. What goes inside your parentheses? And what's your exponent? Is that okay? Alrighty, so last one. A new car worth $20,000 loses 15% of its value each year. Write the equation to describe the situation, then determine how much it will be worth after 7 years. So, what is our rate this time? 15%. So, as a decimal, what is that? 0.15. So, is this going to be growth or decay? How do we know that it's decay? It's losing value, right? So, how are we going to find that decay factor? 1 minus 15%. And what is that? Is that okay? Alrighty, so then write your equation. We're going to have y equals, what did we start with? 20,000. What goes inside parentheses? 0.85. If you're just writing your equation, you're going to have an x up there. We want to know the value of the car after 7 years, so what are you going to plug in for x? 7. So do that, and let me know what you get. Questions on anything? Anything I'm not sure about, don't understand. So you're all good?